Hello, today we're going to be making Benedict solution. It's a solution used to detect monosaccharides in liquids. The ingredients required to make this solution are sodium carbonate, sodium citrate, and copper sulfate. Copper sulfate pentahydrate can also be used and is most commonly used as it is the most widely available. The first step to making this solution is to make sodium citrate. Sodium citrate isn't sold very widely, and so making it is the best decision, since its ingredients are widely sold at many grocery stores. The first ingredient we'll need for this reaction is pure baking soda, commonly found in most grocery stores. The second ingredient is a little bit more scarce, citric acid. It can be found at some grocery stores, but you'll have a hard time looking for it. Now it's time to measure out the ingredients. But first, of course, if we're going to do a reaction, we need a vessel for the reaction. And in this case, the solvent is going to be pure water. For the amounts for each ingredient, first, pure water, 125 grams. Next, sodium bicarbonate, 97 grams. And last but not least, anhydrous citric acid, 74 grams. In my case, my citric acid is 98% pure. So I'm going to have to add a specific amount in order to give it the right weight it needs. Now that all the ingredients are together, begin mixing. First, add the solvent into the beaker. Next, and remember, this is important, add the citric acid first. Final step, slowly add your sodium bicarbonate into the solution. Now, something to keep in mind is that this reaction is endothermic, meaning that instead of releasing heat, it takes heat out of things, like cold packs. And so this reaction vessel is becoming very cold. Almost like ice. The crystals came out looking pretty nice. Now you may be wondering, are they really this big? No, this is a very zoomed in shot. Here's a pencil for comparison. There we go, a singular human hair of that thickness. And there's the crystal. Amazing, ain't it? The final step in this process is to weigh out what we have made. I'm going to expect 100 grams, something around there. I'll probably have less though, especially because this is only one beaker with the crystals, and so it's not my entire yield. The crystals are still wet, even after a week of drying, mostly because the coffee filter crystallized and prevented the water from going through it. Some water still got into the basin, but that water is also saturated with crystals, which we're going to need to get out of that as well. The only option I have left is to set up a dryer. And since I don't actually have a dryer, what's going to have to suffice is an incandescent lamp and some tin foil. Weird looking setup, but it does what it's supposed to, so I'm gonna keep it. No, I'll probably get something better later on, but for now, this is what I have. Well, finally the popping noises have stopped, and that means that my salts are dry now. So let's get them out. I think I messed up. It's making crackling noises. I'm afraid the glass might be cracking. I hope not, but that might be the case. The salts are dried now, and now we can remove the aluminum foil and see what mass has been formed in the beaker. The mass that formed is very strange. It's one solid piece, and yet it looks like it'd be fine like sand and fall apart easily. Well, I have the coffee filter remaining, still covered in crystals, but it's a bit stuck. Well, now we have this thing filled with crystals, and I'm gonna try to get some of the crystals. So let's remove the lamp. Now that we're done making sodium citrate, we can move on to making the Benedict solution. Before we begin making Benedict solution, we should address the problem of dirty beakers. Concentrated sodium citrate solution likes to stick to things, and it leaves the salt everywhere it goes. And so, you get a nice white coating of the salts on your beakers that wouldn't be a good idea to scrape off. What I recommend is the best method to do this is with a bath of hot water. You could just boil some water like you do for tea, or you could get some directly from the tap. Whatever floats your boat. All that matters is that you can get all the sodium citrate out of your beakers. It's time for yield. I'm gonna put in this nacho container. It's just because the chemical name looks like nacho, so we're just gonna call it nacho. So turn it on. So this is stuff I had made beforehand, not part of this reaction, therefore is not significant, and we can just zero that out. But here's the stuff that we have made now. And our final yield is 37.33 grams of sodium citrate. So, in order to make Benedict solution, we're going to need to get the right ratio of salts and the right amount of water. Let's start first by measuring out the salts in order to gauge how much we're going to need of each, especially the nacho, considering that the limited supply means that we're going to have to check if we can do the entire experiment with the limited amount we have. The ratio is 26.4 grams of sodium citrate to 10 grams of sodium carbonate to 26.4 grams of copper sulfate. Beginning with the sodium citrate. Next part is to add the sodium carbonate and the water. So, new beaker. And so, for water, you're going to need 100 milliliters. So, in a surprising turn of events, I do not have enough sodium carbonate. So, now I'll show you an easy way to make some.